Pre-statistics. Exponential functions. Lesson objective. Use the base multiplier property to find an equation of an exponential function. Lesson objective. Example 1. An exponential curve contains the points listed in the table. Find the equation of the curve. Solution. An exponential function is in the form f of x equals a times b to the x power. So our first step is to find the value of a. The value of a is also the y-intercept. It is the value of y when x is 0. So a in this case is 3. Next, to find b, looking at a table, we see as x increases by 1, the value of f of x is multiplying by 2. It goes from 3 to 6. That's multiplied by 2. 6 to 12. So 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. So b is equal to 2. Putting these two values in the form, we have our function f of x equals 3 times 2 to the x power. And we are finished. We can verify by using the graphing calculator. We put the equation in y1. Using the table set, we can make sure the independent and dependent's on auto, and here we have our table. This is the same table of values as the problem stated. So we have verified that this is the correct equation. Example 2. Find a possible equation of the function whose input-output pairs are listed in the table. So when x is 0, we have f of x being 162. Then as x increases by 1, f of x is decreasing, and the amount decreasing is not the same. So this could be an exponential function. Our first step is to take 162 and divide it by 54, and we get 3. Our next step is to take 54 and divide it by 18, and we get 3. 18 divided by 6 is 3, and then 6 divided by 2 is 3. So we are dividing by a constant number. Dividing by 3 is the same thing as multiplying by 1/3. So this is an exponential function. b is 1/3, and we know the value of a is 162. So as x increases by 1, y multiplies by 1/3. That means our base is 1/3. This is a strictly decreasing function. Our value of a is 162, so our function is f of x equals 162 times 1/3 to the x power. We could verify this using the graphing calculator, but I'm going to skip that step. Example 3. Find a possible equation of the function whose input-output pairs are listed in the table. So as x increases by 1, g of x is decreasing. So we go from 50 to 46, from 46 to 42. This is decreasing by the same amount. 50 minus 46 is 4. 46 minus 42 is 4. 42 minus 38 is 4. So this is not an exponential function. So as x increases by 1, y is being subtracted by 4. This is a linear function. So our slope would be -4 over 1. As x increases by 1, y decreases by 4. The y-intercept b is 50. So putting it into our linear function, y equals mx plus b, we have y equals a -4x plus 50. Example 4. Find a possible equation of the function whose input-output pairs are listed in this table. So as x increases by 1, the negative numbers in f of x are increasing. So this may be an exponential function. To check it, we say, what number do I multiply by -2 to get 8? Well, that would be 4. 2 times 4 is negative 8. Take negative 8 and multiply it by 4, we get negative 32. Negative 32 multiplied by 4 is negative 128. Negative 128 multiplied by 4 is negative 512. This is a exponential function. A is negative 2, and b is the value that we multiply as x increases by 1. So for this example, f of x equals negative 2 times 4 to the x power. So if you recall, the base can never be negative. A can be positive, A can be negative. This is the initial value, but your base has to be a positive number. Example 5. Here we have a different table. As x increases by 1, the y's are decreasing, and it's clear that this is not a linear because the amount that's decreasing is changing as we go down. If you recall, this is scientific notation. This is 9.8 times 10 to the negative 4. So in standard form, this would be 0.00098. Is this an exponential function? Well, there has to be a constant number that's multiplied as x increases by 1. So what number do we multiply by 1 to get 0.25? What number do we multiply by 0.25 to get 0.0625? It may help us to think about these decimals as fractions, and that may help us see the pattern. So 0.25 is the same thing as 1/4. 0.0625 is the same thing as 1/16. So the pattern would be 1, this is 1/4, this is 1/16, this is 1/64. So as we go from 1 to 1/4, if I take 1 and multiply it by 1/4, I get 1/4. If I take 1/4 and multiply it by 1/4, I get 1/16. If I take 1/16 and multiply it by 1/4, I get 1/64. So this is an exponential pattern. As x increases by 1, y multiplies by 1/4. So that means our base is 1/4. In this case, a is equal to 1, and therefore our function would be simply 1/4 to the x power. Our last example for this video, example 6. As x increases by 1, in this case y is increasing. And again, it's clear that this is not linear because it's not increasing at a constant rate. These numbers are getting larger and larger and larger. Usually that's a sign that's exponential. In order for this to be exponential, as x increases by 1, these values have to be multiplied by the same constant value, b, the base. So what number do we multiply by 1 to get 2.5? Well, that answer is 2.5. If I take 2.5 and multiply it by 2.5, do I get 6.25? And the answer is yes. If I take 6.25 and multiply it by 2.5, I get 15.625. So this is an exponential function. The base is 2.5. Again, the y-intercept is equal to 1. So putting a and b into our equation, we have f of x equals 2.5 raised to the x power. And we are finished. Summary. Given a table of values, if the relationship is a linear function, then as the independent variable increases by 1, the values of the dependent variable change by the addition or subtraction of a constant number. So as x increases by 1, either the values of y are going to increase by a certain value each time or decrease by a certain value each time. Given a table of values, if the relationship is an exponential function, then as the independent variable increases by 1, the values of the dependent variable change by the multiplication of a constant number called the base. So usually with an exponential function, the dependent variables increase very quickly or they decrease very quickly. And that is because it involves the multiplication of a constant number. Thanks for watching.